what we're going to talk about today is why you need to consider electricity energy efficiency in general, but electricity efficiency in particular in your GHG reduction plans, even in the situation. So I'm Jay, I'm with Director of Programs Operations for Goldman Consulting on behalf of Energy Manager Support Services of Save On Energy. I have Christy, Augie, and Andrew, my colleagues, who will be helping out, facilitating the chat and the breakout room that we're going to be doing later. And of course, Helen is here making sure everything runs smoothly as our producer. What we're going to be talking about today is we're going to start off with a quick look at the benefits of a holistic approach and what we mean by that, just to kind of set the stage. Then we're going to start talking about what are some of the risks of ignoring electricity in your decarbonization efforts, strategies, and plans. And then we're going to do some work together in those breakout rooms around ideas of how do you build support for those projects, for that holistic approach to minimize those risks. All right, so we're starting off with a situation where you have been tasked to find projects to support an aggressive emission reduction target. So we have here 50% by 2040 as a hypothetical case, and as your priority is projects to reduce GHG emissions. Now, this may not be an entirely hypothetical case for all of you. We've just had a couple of record-breaking October temperature days, so hopefully it will be less hypothetical for many of you as we continue to move forward. But what we look at, let's start looking at the energy breakdown. So, this is based on rough industry averages by sector, but in general, you're probably somewhere around a 60-40 split of natural gas and electricity. If you're, a really heating intensive industry, maybe it's a bit bigger on the natural gas. If you're something like office buildings where, there's more of a cooling load than a heating load, and you have more like electrical equipment on site, it may skew a little bit the other way. But this is sort of generally where most people will land. But this is on gigajoule basis. If then we translate this into where those emissions are coming from, and this is Ontario context, this is your emissions. So probably about 90% of your emissions are coming from natural gas combustion, and only about 10-ish% are coming from electricity. So going back to our hypothetical situation, you're trying to get a 50% reduction. If you reduced your electricity consumption by half, that's like at best maybe a 10% reduction in GHG emissions. So that's probably not where you're going to be focusing your efforts when your priority is reducing GHG emissions. One of the things that this points out, if you're looking at a 50% or greater reduction in GHG emissions, you're probably not going to get that through improving efficiency of natural gas. It might be possible, but that's like a 60% reduction through efficiency. That's going to be very difficult. You're probably going to be considering electrification at some point, if you aren't now, at some point in the future. Or like renewable fuel switching, something like I saw Alan with a little shake. But we're going to make the assumption that somewhere along the line, you're looking at electrification. But also remember, if we look at the costs of energy, these charts flip. And 70 to 85% of your energy costs are on electricity. So that's going to be part of the context to remember. One of the comments earlier when we were looking at has this impacted it, depends on your evaluation criteria. A lot are focusing on GHG reductions, but let's not forget there's other priorities within organizations, including operational costs. And this plays a big role in that. When we talk about the holistic approach, what we mean by that is there's many ways to reduce greenhouse gas emissions, different strategies. So the holistic approach is considering those different strategies. You can, reduce the carbon intensity of the energy sources or process inputs coming into your organization, that sort of left-hand arrow. You can capture the greenhouse gas emissions after they've been released from combustion on the right-hand side, carbon capture, utilization, storage. You can reduce fossil fuels on site through electrification or other approaches on that. And lastly, although it's at the top of the image, you can reduce the amount of energy you need through improved efficiency. So those are the four primary strategies to consider. And the holistic approach means not necessarily doing all of those, but considering all of them and what makes sense for your facility or organization, as well as considering all of those fuel inputs, not focusing just on one particular area. To look at that a little bit of why that efficiency component is really important. Now, we've seen people start off at different points, focusing on electrification, focusing on efficiency, fuel switching, different things like that, purchasing renewables. The starting point isn't as important necessarily, but considering efficiency is important. Does anyone know what this chart is? Has anyone seen this before, or a chart like this? I see one hand up, but it was from Andrew, and I feel that is a bit cheating because he's on our team. For those who aren't familiar with it, the term is a marginal cost abatement curve. And what it does is it compares a range of measures to reduce carbon emissions. And the width of each column is how much it can reduce in terms of emissions, tons of CO2e, and the height is the cost. And the negative values are projects that deliver cost savings, and the positive values, the ones above that horizontal line, are ones that are a net cost to reduce those emissions. And one of the great things about this graph is that it lines them up from the left-hand side, the projects with the greatest savings while reducing emissions, to the ones on the right with the greatest cost of reducing emissions. Now, this graph is old. I think it's like 2007, so it may not be entirely up to date on technologies. It's looking at country level measures as opposed to options in a facility. It's also too small to read, but specifics on this aren't important. What I want to do is highlight generally where those 4 different strategies fall to show why energy efficiency is so important. So we start off with carbon capture, utilization, and storage, which ends up on that far right-hand side. It's costly. When we start looking at low carbon fuels and energy sources, we're starting to move to the left, the less costly areas. It's a bit of a wider range. When we look at electrification, again, a bit more of a shift on the left, and we're starting to see more of those leading to net cost savings depending on what is being electrified in the application. And then lastly, we look at efficiency, and that is really what dominates that left-hand side of the chart. Those projects that not only reduce emissions, but also generate cost savings. Now that's efficiency in general. And I would like to do a little bit of a brainstorm of what are the benefits, not just of energy efficiency in general, but specifically electricity conservation, improving the efficiency of electrical systems, equipment within your facility in your GHG reduction efforts. So as you have your GHG reduction efforts, your strategies, what are the benefits of including electricity conservation? So you can raise your hand if you want to share it verbally, you can type into the chat, you can annotate on the screen with the Zoom controls, whatever you're comfortable with. But we saw before that those electricity savings in Ontario in a low carbon intensity grid, they're not going to help a lot with your GHG reduction targets, but what benefits might you still get from including electricity conservation in your GHG reduction efforts? All right, so I'd love to see some of those. I think Max wants a mini movie of that progression of where the different projects fall on that. We'll see what we can do about that. Does anyone have any experiences from their side around that they'd like to put up their hand and maybe share with the group around some of those benefits of looking at electricity? We see from Nathan benefits of cost savings due to electricity, offset the low cost benefit of gas savings. There we go. They're like, we've definitely seen organizations do that where, you know, the cost savings on the electricity side, most of your energy costs are with electricity. Great benefits there. Everyone's caring about the operational costs, reducing, minimizing. Or we've also seen taking that GHG reduction efforts, looking at a portfolio approach and using cost savings from electricity to offset potentially increased costs from fuel switching, from switching through electrification from natural gas to electricity. I think Max has a really great point there in the chat around, building that culture, behaviors, attitudes within the plant, that culture of sustainability, efficiency, conservation that has long-lasting benefits. When you start asking people to participate in this and then start chopping off, it's like, oh no, I don't want that idea. That's yes, we asked for efficiency reductions, but not that one. These ones over here. That can really impact behave like employee engagement on these efforts and building support. So taking that holistic view and taking all those opportunities is important. Technological availability is a good one, encouraging conservation behaviors in general. So there's a lot of good benefits to including electricity in these efforts that we can get. So thank you everyone for your contributions. Now I want to flip the question a little bit. We're going to go back to Menti. So we talked about the benefits of including electricity in your emission reduction efforts. What are the risks of ignoring electricity conservation and efficiency as you are reducing your GHGs? Now, sometimes risks are just the opposite of benefits. So we heard like, hey, a benefit of looking at electricity is reducing operating costs. The risk is higher operating costs if you don't look at electrical projects. But there may be others as well. And we've already seen these starting to pop up as organizations are going through these efforts. So I would love to hear examples. You can use Menti to record them. Go to menti.com, enter that code. Helen has the link in the chat. All right, so transitions to electrification later make equipment more expensive, right? There could be capital costs associated, risks around those, not just the operating costs in moving to increasing your electrical load, but also the capital costs associated with that, opportunity costs, risks around future electrification. That's a little bit general. We'll get into some of the different risks around electrification later. Uncertainty, there's an interesting one that I think we're really gonna touch on. Not just the risk of higher utility costs, but the risk of greater uncertainty. Weakening of energy awareness conservation efforts. I like that one a lot. Again, when you start partitioning things out, it can weaken that engagement and around it as well. Electrify now while it's available. All right. These are really great. I love these risks. And as I said, we've started seeing some of these already showing up in organizations and manifesting themselves as we start down this energy transition pathway. If we wanted to group these, I think there's uncertainty around costs. We mentioned the increased cost, but also increased uncertainty. As we go through this transition, rate structures might change. We don't know necessarily where they're going to end up. We kind of saw a hint of this last summer when natural gas prices spiked due to global conditions. And there was a shift in electricity rates from global adjustments to market price of electricity. And I know at least a couple of organizations that were hit hard with that because they had focused on managing global adjustment and ignored conservation efforts, that when that shift happened, their monthly electricity bill went up 30%, like six-figure range on it, because they had been ignoring conservation efforts. So there's going to be uncertainty around how things play out as well, and reduced resiliency to respond to those changes as well if you aren't looking at electricity conservation and demand management type stuff. There's risks around capacity limitations. So we saw people mention risks around electrification. You may, if you're not focused on electrical efficiency, you may end up requiring panel upgrades. You may have challenges connecting to the grid, like limitations around local transformer capacity. At a system level, even potentially grid reliability if that efficiency is not taken into account. Risks around equipment, I think it was mentioned, like oversizing things, inefficient equipment, inefficient electrification. We've seen people going for boilers, not looking at how to smartly manage electrical demand, and also the risks around stranded assets. If you're not focusing on electrical efficiency early, you may end up in a time where you've replaced equipment and then 5 years down the road, you are looking at improving its efficiency, but that is then replacing a relatively new asset. And that's not a situation you want to be in. You want to be considering that efficiency. And lastly, there's risks around achieving those GHG emissions. So one thing to highlight that we've seen come up in some planning exercises is increasing scope 2 emissions. Ontario is projecting that the emission intensity of the grid is going to increase between now and 2040, like about 300%. Even if it's still clean relative to other jurisdictions, that's a big percent increase. The other thing, if you are, one of those strategies is renewable purchases through renewable energy credits, clean energy credits. Keep in mind, those are based on a per kilowatt hour basis. So if you are not using electricity efficiently, you're going to have to buy a lot more of those credits to reduce those scope 2 emissions. The next thing I want to do is go through kind of a little hypothetical case study that highlights some of these. But before we get into that, are there any questions about any of the risks that came up, either that people contributed on the Menti or that were mentioned here? Okay, so we'll get into that. And we're going to look at two hypothetical facilities. These facilities are identical. They have identical GHG reduction goals, but one of them, facility A, saw that chart at the beginning that's like, oh, 90% of our emissions are coming from natural gas. We are going to deprioritize, ignore electrical efficiency. We're going to ignore that. We're just going to focus on natural gas conservation and electrification. Facility B is taking a holistic approach that is looking at energy efficiency in general, including of their electricity use. So if we start looking at their early efforts before they consider electrification, facility A, focusing on natural gas, they're getting higher emission reductions than facility B, who is looking at natural gas and electricity efficiency. But facility B is achieving greater cost savings on that because of the high cost of electricity relative to natural gas. When we get into them looking at electrification and going through that transition, facility A didn't take electricity conservation into account to reduce existing demand, and they're not pursuing efficient electrification. So, they're installing electric boilers because that's easier. They aren't installing advanced controls to manage electrical demand and the time of use, which means a significant increase to their electrical demand and their electrical consumption. This increases their utility costs moving forward, but it also generates a delay because there's additional capital costs. They have to upgrade their panel to handle this increased demand. There's local utility constraints at their transformer station that causes delays. So those electrification efforts are pushed back relative to facility B, which has already reduced their demand through conservation efforts earlier. They are planning efficient electrification using heat pumps, advanced demand management controls. So they were able to avoid those additional energy costs and delays of the facility B. Both of them get the significant emission reductions of switching from natural gas to electricity through electrification. But there's timeline delays, capital cost risks around there, and then operating costs in terms of utilities. When we look at after they've gone through that electrification process, because facility A didn't consider electricity conservation demand management during electrification, not only are their utility costs higher, but they're less able to adapt to uncertainty, to changing rate structures. So they have higher costs and greater variability and uncertainty around those costs. And they also begin to see their emissions increasing as the grid emission factor increases over time, which puts achievement of their GHG reduction targets at risk. Whereas facility B, because they electrified efficiently, they're able to minimize the risks, costs around utilities, better adapt to changing rate structures and take advantage of those. But also, because they've been reducing their electricity consumption previously and continue to do so, that increasing grid emission factor is mitigated. So they end up in a better place, both in terms of GHG reductions and cost impacts than facility A. Now, these are overly simplistic comparisons and kind of at the extremes of like completely ignoring electricity and taking that holistic approach. So, there is that on it. It's used for illustrative purposes, but I will say that all of these issues that have come up are things we have seen in real life. The risks around panel capacity, around local transformer capacity, the risks around not being able to adapt to changing rate structures. These are all real things that we have seen. Max asks us, the risk of grid emissions increasing is real and widespread. This is Ontario context. So this is pulled from the IESO's annual outlook report, where they kind of like project into the future. It's also, and primarily it's because as demand is increasing, we're looking at using more natural gas plants to meet that demand. So it's very jurisdiction specific. Many jurisdictions in the states that have really high emission factors are projecting reductions in those. It's also not certain. There's lots of changes in policies. As I mentioned, this is a big energy transition. There's a lot of uncertainty involved around it. But this is using kind of current projections that we have specifically for Ontario. With those risks in mind, and there's a little bit of a summary here of some of the key risks that showed up in the case studies. I want you to think about, what do you see as the biggest risks to your organization? The ones that may worry people the most as you're going through this transition, as you're looking to hit your GHG reduction targets. Which ones are people, if you brought these into your organization, which ones would worry people the most? Is it delays in getting those reductions in place? Is it capital cost? Is it the operating costs? What might it be? And please share in the chat. Again, there's some space to annotate or raise your hand if you would like to discuss any of these potential risks and what they might look like in your facility. On page 3 of your workbook, there's also space to write these down. And we're going to have some discussions right after this about that. So I'd really like to hear some of those, identifying, 1, 2 of what you see as the biggest risks of ignoring electricity efficiency in your efforts. See a comment from Max around costs and uncertainties. Capacity constraints are a big one. I think there is a lot of concern around that as well. Would anyone be, plant limits, integral grid. Anyone be willing to come off mute and share what these risks might look like for your organization?
I can volunteer.
Sure, Max.
So we're looking at this globally, electrification, and we're looking at it quite aggressively, but we're already seeing that in some areas where we would like to do it, that there is things preventing it, like grid capacity is one. Also the availability of companies to actually do the work, and the timelines with getting the stuff built. When we've been shopping around, they've got long delays on how long they can put projects in. So we then had to go to somebody else to be able to supply it within the timeline. And I can imagine that that's going to increase. So we're actively looking at not only the jurisdictions where it makes sense to electrify now because of incentives, but where maybe 6 months, 12 months, 18 months down the road, it's going to be a cleaner grid in that area, and therefore we're going to be electrifying there. One of the things I hadn't considered so far that you brought up in the last slide is that the grid emissions might actually increase in some of these clean grid areas because everybody is jumping on the electrification in that zone. But yeah, it's mainly around the grid capacities and the availability of technology and availability of grants to enable the cost. Yeah,
and I think those are interesting. And like I said, we've seen these in real world. We've seen facilities that have planned electrification and reached out to their local utility about, hey, are there capacity issues? And that has caused barriers and delays and challenges with it. We've also seen planning, like we're looking at Ontario's grid, the emission factor increasing with current projections, and it's still low relative to other jurisdictions in North America. We would still have it, but relative to what we are now, the percent increase might be significant. And I know working with some companies on sort of laying out that, like, what is that pathway to hitting the target, it's come as a surprise to some of them as well. So I think the risk of that has been interesting. There's a number of other comments around capacity, risks, limitations around that. Darren has some interesting comments around, around cost structures and understanding those and being able to adapt to those, and what changes and how you pay for electricity or what generates those costs. How did that manifest? And I think that's going to be, I'll use the word interesting. Not everyone might use the word interesting, but as we go through this transition, there's a lot of uncertainty around what that's going to look like. We've also seen some jurisdictions, or in some sectors like residential, having like ultra low overnight rates. So it's not just the risks of being stuck with a poor rate structure, but what are the risks of, or the opportunity costs of not being able to take advantage of, a beneficial rate structure that comes out. So hopefully everyone has highlighted a risk to them, because what we're going to do now is we're going to send you off into breakout rooms. So get ready to, if you're comfortable, turning on your camera, coming off mute, getting ready to chat with each other, get some discussions going. In these rooms, what I want you to talk about is, start off with what is your biggest risk? What do you see as a risk to your organization, to your facilities on there? Once you've heard some of those, I want you to think about, why is that risk maybe not getting the attention or resources it deserves? So we saw in our initial question that, some people are deprioritizing electricity conservation in favor of natural gas projects, and sometimes it's harder to get those in. So why are some of these risks or issues not getting the attention that they deserve? Are people not aware? Are the right stakeholders not involved? Is it not really built into your planning properly? Why are these risks not getting the attention? And then lastly, I want you sharing ideas and brainstorm ideas of what you could do to build support around mitigating those risks. So based on why it's not getting the attention or resources it deserves, what might you do to get that attention and resources? All right, welcome back, everyone. I'm really curious on hearing how some of the discussions went, and in general on any of those points, but in particular, any ideas that came up around strategies to build support for that holistic approach to mitigate those risks of not looking at electricity conservation within that. Andrew, Christiagi, do any of our facilitators want to sort of get things rolling on there? Just before I do, I will mention, page 4 of the worksheet, there is some spots to write down good ideas that you hear. We have space for categories, like ways to use information, or who should you be talking to, what stakeholders internally or externally, or ways that you might improve planning to get this support and mitigate those risks. So please go to page 4 of your workbook if you want to take notes on that. But yeah, Andrew, your hand's up. How are things in your breakout room?
I put my hand up because I was just dying to let Sung Yang finish a point that he was making. And I'll try to summarize it. And then if I get it wrong, Sung Yang, jump in and tell me. And if you need to elaborate, that's cool too. But at University Health Network, they're going with wastewater heat transfer, which is going to electrify a lot of their heating. And Sung Yang was saying his opinion is that kind of project is one that, and I'm maybe inferring a bit. So again, Sung Yang, you can correct me, but that kind of project actually shows that they are being mindful of electrical efficiency as they electrify, because it's possible and maybe potentially capital cost wise cheaper to try to put in a bunch of air source heat pumps. Now it's a big hospital, so that would be a lot of air source heat pumps hanging off of it. But air source heat pumps would have also been much less electrically efficient than wastewater energy transfer. So by going for the more efficient form of electrification, he's sidestepped, like not just, this is not just an idea for avoiding the risk, but he's already sidestepped a fair amount of risk.
Yeah, and I think it's a really great point, and we've been hearing a lot about the importance of that efficient electrification and making sure you're looking at that. And there's different ways, like if you're starting to plan that, there's different ways to like make people aware of the importance of that or the beneficial. Like we've seen organizations move to like total cost of ownership analysis when evaluating these projects. Because I've seen organizations switch to electric boilers and electrification because it's easier, lower capital cost upfront, it's cheaper, but then you're dealing with really high utility costs, but also potential capacity issues and other things like that. So making sure that it's not just capital costs you're looking at, it's total life cycle costs or total cost of ownership could be one of those strategies that like bringing that information in versus just looking at limited information around the capital cost of it. Any other interesting points that came up in those breakout rooms? And if you have your own or heard from someone else's that you thought was good, please also unmute and share that or put your hand up and I'll get to you. But I'm going to jump to Augie now while we wait for others to find that unmute button.
Yeah, the big, thanks, Jay. The big theme kind of that was shared among a few people were capacity constraints. And some folks were very proactive about it. Max, I think, shared already in the chat earlier, kind of reiterated the struggle that or the challenge that he's faced, what he's heard back from his LDC. In that, looking at some preliminary numbers around electrification, there simply is no grid capacity at the point, at the moment. And so they're looking at, other strategies to overcome that humongous barrier. And that was shared among the group as well. And a bit of a wide spectrum as to where people are in terms of like actually reaching out or quantifying, reaching out to the LDC, and quantifying what that, additional load would be. But yeah, if we have time here, Jay, I would probably even invite Max to share a little bit around what he shared.
That would be great.
Yeah, so we've been looking at it sort of twofold. Initially, we would take our boilers and the idea of electrifying our boilers, and we would just look at our boiler capacity. This was just a simple exercise to check on available grid capacity, determine what we would need to ask for. We would look at our capacity of our boilers, and then imagine we were connecting that to a heat pump with our cold source in the plant and how much electricity that would require. And then we just go to the local utility and ask, can you supply this much electricity? Because that would be our big electrification project. And probably about half of them, it surprised me, came back and said, no, we either don't have the capacity to provide that electricity, or when we switched the conversation to, well, what if we had renewables on site and we're like that feed in, feed back, and they're like, yeah, we can't even take the electricity from us. And then Darren made a good point, sort of following on from that it may not just be the grid ability, but also like the legislation and the red tape around on-site generation and those issues. And that was another thing that I hadn't considered and kind of went on some other aspects. But in terms of the strategy around this for building a holistic approach internally, I think what I'm going to be taking is all the different challenges that popped up in the conversation. I'm going to take those challenges to my management and be like, look, these are things that are real, that are happening in not only our areas, but others. So we need to start paying more attention to just the small electrical efficiency within the plant, things that we can controlling the controllable within the plant.
Mm-hmm. And there's a couple things there I love in terms of the strategies to build that support, is like bringing that information to them, It sounds like you've done a really good job of talking to the right stakeholders, both like the internal ones to get that information around the boilers, heating what's needed, but also the external, those LDCs, talking to them early. I can't stress that enough. And bringing that focus and showing the information of why we need to bring it back to conservation and efficiency. I know a sector, I'm not sure if anyone on the line here is from it, but mining and industries up north, traditionally, they've had capacity issues, just in terms of transmission lines that are reaching these remote sites. And a lot of times, if they want to expand their mine or grow, they have to find ways to conserve or use the energy more efficiently. Otherwise, there's just not capacity for that. So I think that's a sector that has a lot of experience dealing with capacity constraints and can be used to show them that value of, all right, we need to conserve to make room for. The other part of that I think is worthwhile in gathering information is we've seen a lot around smart controls of electrified systems. So it's not just the amount of electricity consumed, but also the timing of it. We're expecting to see peak shift from, summer afternoons, early evenings to cold winter mornings when you heat up from a backset or from like a setback overnight. And that can partially be mitigated by, advanced controls and how you're controlling that equipment and when that demand is coming online as well. So I think there's some great points there. Anything, and Christy, were there any interesting conversations happening in your room?
There were, and quite a few sectors represented in our relatively small group, which was great. So and really good examples, but very specific seemingly to each subsector. And to kind of summarize those, I tried to include them here on the board, but keeping conversations open with the LDCs about whether or not there are regional constraints or will be. We talked a lot about the business case, so budgets being the biggest constraint, but how do we make sure that there's that balanced and holistic approach when putting business cases forward? And part of that for some is ensuring that there's good quality data, utility data, and even sub-metering in place so that they can show the impacts that their projects are having or facility changes are having on their utility costs and emissions.
Great. Yeah, and I think that the getting the data just on the electricity side as well, like what information can you use? The other thing we talk a lot just in energy management in general is quantifying all the other benefits, or that the benefits that aren't being achieved if you're ignoring certain areas or don't have the resources to pursue electricity conservation as well. So those non-energy benefits, the benefits to equipment reliability, those benefits to health and safety, to other aspects of your operations, and the cost savings, and highlighting those. One thing that I haven't heard a lot was, the third category that we have on the sheet are strategies of how you can improve your planning process, or what those plans look like. And I'd love to hear if there were any examples or ways that came up in the discussion.
So I have two things that came up that I think I can relate to planning. So I'm going to try to tee up Vidal to make a point that he was making in our group. And I'll say that the way that this connects to planning is that he was really talking about making sure we forecast things properly, right? So we look at different scenarios and we're looking at all of the important things in them so that we pick the best one to be our plan. But the way I want to kind of introduce this is just, I saw something I can't remember when, a couple years ago, that was saying, if you want to talk to executives, if you're looking at the people who are making decisions about whether you're going to go with efficient electricity or not, the things that they'll care about are finances and, things like the bottom line, risk, and market share. And I think I'm certainly guilty of this. I think in general, as energy managers, we focus a lot on the finance part and don't talk about other things. But Vidal brought up a really important risk element in projecting things properly around electricity. Vidal, are you still, can you hop on and just explain what you talked about there as far as unit cost?
I think the main point was really just given the uncertainty for the trajectory of, let's say, electricity pricing, giving it in itself is a very convoluted market, and try to explain in lay terms to anybody, right? But when we're looking at that, let's say vis-a-vis natural gas pricing with the carbon pricing regime, the uncertainty for that, I mean, there's so much uncertainty for where these prices are going to be 2, 3, 5, let alone 15 years from now. So when we're putting together business cases, it could be, I mean, fairly easy to put together an oversimplified approach or trajectory to where these unit costs are going to go. So really, I mean, that in itself is a risk. We don't know where things like electricity policy will go or carbon pricing regime will go in several years from now. So the case for energy efficiency really does help in some ways mitigate some of that, because we're buying less energy off the grid to begin with. So that's seen as a pretty good case to take a holistic view as far as not just the decarbonization, but let's try to reduce our overall demands at the onset.
Yeah, and one thing on that planning side that I've seen happen is, instead of presenting, hey, here's our anticipated costs or our expected savings, that kind of stuff, is presenting different scenarios. Because like you said, there's a lot of uncertainty that's out there. And, here's scenarios where, we have a lot of flexibility, we've conserved, and different rate structures, different things that happen, to highlight not just those costs, but that uncertainty. And it could go here, but it could go here. And that spread could be pretty big. And we can narrow what that spread might be through conservation, things like that. Stephen, I saw you come off mute there.
Yeah, I just want to endorse everything everybody said there about that. But I'm going to add one thing to it, and especially with what you just said, Jay. If you're looking at doing risk and sensitivity analysis, there's a wonderful tool set in RETScreen. You don't have to use RETScreen to do your technical analysis. You can dive in under the cost section, and you can dial in your own savings, calculate elsewhere. But there's a nice Monte Carlo tool for doing risk and sensitivity analysis, where you can simulate out into the future, right? How many years? And do the crystal ball thing, but it will give you a range of likely outcomes. So rather than going to, this is the answer, this is the worst case, this is the best case, right? So I think that's an important one as well. And the other piece that I would add to that, in a similar vein, is life cycle costing, right? Because none of these things are going to have a simple payback, right? Let's face it, simple payback doesn't work in this situation. But using life cycle costing, and I don't mean now in RETScreen, the financial analysis, I mean using life cycle costing, where you cost out, say, 3 different scenarios, but those scenarios can be 3 different permutations of the future conditions. But you can also, from a planning point of view, you can also roll in all those varying carbon taxes and other costs too, right? And just show which is the best life cycle cost or the lowest life cycle cost. I think that's where life cycle costing has a lot of merit in this type of thing in planning.
And I think like the life cycle costing, total cost of ownership, that's a big thing too, and it really does sort of highlight the importance of efficiency and operating efficiency within that. The other thing I've seen on the planning side, and that's come up with some of the work we've done directly with companies, has been when you actually lay out that path. So you have a 2040 target, 2050 target. When you actually lay out, okay, what does it look like to get, what is our path to get to that target? You start being able to highlight some things around, what does it mean if the grid emission intensity factor increases? What does that mean to your scope 2 emissions and achieving of your target? What does the purchases of renewable energy certificates, how does that do? So like when you actually move away from, and we kind of saw that in that case study where it was like, at the beginning, focusing only on natural gas looked pretty good. You didn't get all the cost savings, but you were getting pretty significant greenhouse gas reductions. And it was only when you started looking longer term that a lot of those risks showed up. So moving that planning away from just the immediate projects that you're looking at now to be like, okay, what does it mean to get a 50, 60, 80% reduction in our carbon emissions, and what are all those different risk factors that come into play? That can paint a very different picture than, you know, the immediate short term, I need to reduce a certain amount this year or next year.
So I'm going to pop off early, Jay, not right now, but I'm just giving an advance warning. But I think I can open a bit of discussion that Raphael started in our group before I go. And it's really related to what you're talking about in scenario planning, you know, projecting utility costs, as well as Vidal's point of reducing risk. Now I'm really excited about this Monte Carlo tool too. I forgot about that, Stephen. Thank you. You know, for a lot of years, if people talk about building envelope upgrades, right? You kind of see people scratching their heads, being like, "How are we going to pay for that? That doesn't pay for itself." But Raphael brought up that, you know, if you're projecting and if you're looking at life cycle analysis and you're projecting utility costs into the future and you're electrifying, then you really need to think about building envelope because of how much it impacts, for example, your heat pump and how that heat pump is going to demand electricity to provide heating and cooling. Stephen also then in talking about that, talked about how improving your building envelope will dramatically reduce the capital costs of a thing like heat pumps. And so, you know, what Raphael started with, this is in the risks section when he started talking about this, he's saying, you know, one of the things that I think he was saying, one of the things that prevents people from really wanting to get deep into electrification is that if they really know what they're doing, they're going to connect the dots and say, that means we need to do building envelope upgrades. And that's going to be a challenge. Mm-hmm. So I think, yeah, I'll open it up to Raphael if he wants to elaborate on that. And also Stephen then added, not just building envelope, but mechanical equipment, how you can't ignore those things when you're electrifying, and any kind of scenario planning, life cycle assessment, or projection to the future needs to include those projects, which are costs.
Raphael, did you want to comment on any of that and how those you may be mitigating those risks in your organization?
Andrew actually covered most of it and connected the dots perfectly. Thank you.
Okay, great. And I think that brings up, you know, one of the other important strategies of building the support that we've seen, and that has been a really great success factor in a lot of organizations, has been integrating these decarbonization efforts into other planning that is happening in your organization, whether that's like, you know, capital equipment end of life planning, capital asset renewal in terms of buildings or new construction, and making sure that the planning that you're doing around decarbonization is fully integrated with those other plans, because, you know, those equipment renewals, building retrofits, new construction, those are 20, 30-year investments in a lot of cases. If your target's 2040, 2050, you have one chance to get that right. And so having that planning in place and incorporating, you know, efficiency into those planning decisions, it really is critical in this area. All right, I'd like to thank everyone for participating in that and sharing these different strategies. Now, one thing that I want to tie this back to is the Save on Energy program is promoting strategic energy management at the moment. And a big part of the reason why is it helps build this in. And I want to just highlight how strategic energy management and taking that approach can help with a lot of the strategies we just talked about. Because we've seen some of the strategies that came up here, things we've seen work well, a lot of those key success factors align really well with aspects of a strategic energy management framework. One of those big ones is around management commitment, and strengthening that management commitment to a holistic approach that balances those different priorities will really help mitigate those risks. The other part around the commitment is committing not just to that long-term goal, but what are those either supporting or interim commitments standards, targets that can be set to help support in that, to break it down from a long-term look to something that's more achievable and has building blocks in it is really critical. We talked a bunch about planning there, but making sure that you are looking at those longer term plans for that holistic approach, because not only does it help you identify those risks that may be down the road, but it also is really important to align timing of those different strategies, right? That holistic approach, you're considering all 4 of those strategies, but different organizations may prioritize the timing of them at different times. So looking at that long-term integrated planning approach is really important and helpful at making sure your organization is taking that holistic focus. Looking at the opportunity identification and implementation component of strategic energy management, it's, part of it is really understanding the impact of process equipment. I think Max made a good a point there around understanding what are those boiler loads, where are those opportunities, what is that going to look like, and then when you've identified those opportunities, you can start prioritizing them, not just against the short-term greenhouse gas reductions from natural gas consumption, but across those multiple priorities that touch on different risks within your organization. We talked about employee engagement and making sure that you are developing that culture of conservation, sustainability, encouraging people. There were a number of great comments in the chat around wanting to get people engaged, and you don't want to sort of limit or narrow that engagement. You are looking for that broad engagement towards these long-term goals. We look at that operational integration and making, monitoring and reporting, making sure you're regularly reporting on it. And one thing we talked about today, we talked about a lot of those risks. And I think I know a lot of you on the call, and you're already doing a great job of reporting progress against targets, but starting to bring in some of this information to highlight where those risks may be showing up into that reporting, and highlighting that in how things are going in your irregular updates can be really powerful to get that buy-in and support. We have that operational integration. I think we've heard from a number of people around that importance of de-siloing your efforts. This is something that different groups in your organization need to be involved in, and looking at, that total cost of ownership, that life cycle cost, building it into design procurement decisions so that you're not operating as, the one person advocating for efficiency improvements. And lastly, that framework of continuous improvement. There's a lot of talk today around uncertainty, around being flexible and able to adapt, and having that continuous improvement of, what's working, where are the gaps, how do we fill those, is just going to become so much more important as we go through this transition with all the uncertainty that's involved in it. I'll leave you with some places for additional support. Again, there is a strategic energy management program to help you implement all those things, which will help you with that stronger, more resilient holistic approach to energy and carbon reductions. So if you aren't aware of that or haven't applied yet, I know a lot of people on the call are already in the program, but if you haven't, please do so. You can also earn performance incentives while you're getting all of this help. Also, if you're not quite sure about the strategic energy management program yet, you can sign up for energy manager support services. This workshop has been part of that, but you also get access to online courses, other resources, and you can connect with peers, expert coaches to ask questions, get input, get support through that means. And there's no obligation. It's just you register and you get access to our online learning platform and these services. And lastly, in the worksheet, we do have links to some of the resources that I mentioned today. So I recommend, if you're forecasting out, you can look at the IESO's annual planning outlook or their pathways to decarbonization reports. It came up, there were some great suggestions from Max and others about talking to your LDC when you're planning on making these changes, electrification, involving those stakeholders. They're a great resource in terms of understanding what are those local constraints, because oftentimes it is at that local transformer level.